One says draw a square with an area of 4. A square with an area of 4 is a square made up of 4 boxes. Can someone tell me what its side length is? Go ahead. 2. So, 2 times 2 equals 4. 4 is a number that makes a perfect square. The square is perfect because it has integer side lengths. Number 2 says draw a square with an area of 25. So this has 25 squares in it. 1, 2, 3, 4, 5. The side length is 5. 5 times 5 is 25. 25 is a perfect square because it perfectly makes up a square that has integer side lengths. Can someone tell me 2 numbers you multiply together to get to 25? Go ahead. 5 times 6 is 30. 5 times 5 is 25. So the square root of 25 is 5. Square roots are numbers that you multiply to itself to get that bigger number. So 5 times 5 is 25. The square root of 25 is 5. Other than 1 times 25, is there a different way to get to 25? Go ahead. Other than 25 and 1. Go ahead. Ooh, okay. That will work. Are there other integers we could get to 25 with? Go ahead. Negative 5 times negative 5 is also positive 25. So, when you have this negative out in front of your square root, the negative square root of 25 is negative 5. So the square root of 25 is 5. The negative square root of 25, or the opposite of the square root of 25, is negative 5. So what's the difference between negative square root of 25 and square root of 25? Oops. Go ahead. Okay, so that's the only difference. One is positive and one is negative. So because 5 times 5 is 25 and negative 5 times negative 5 is also 25, we need a way to express which answer we want, if we want the negative root or the positive root. Number 8 says draw a square with an area of 30. If I tried to draw this square, here's my 5 by 5, which is 25 square. If I'm adding another square, I need to add on some in both directions. So now my area is 36. So we can't make a square with an area of 30, which means 30 is not a perfect square. The closest you would get is this 5 by 6 rectangle, which isn't a square. So, things that are not perfect squares are numbers that you can't make into a square with integer side lengths. Alright, 0, 1, 4, 9, 16, etc. for number 9. First, can someone tell me what this pattern is? Go ahead.
It's adding to odd numbers, like increasing by odd numbers. So 0 plus 1 plus 1, and 1 plus 2 plus 4.
Okay, so we are getting bigger that way. Go ahead.
It's a square.
Not square roots. What's the opposite of a square root? Go ahead, Yassine. Okay, does anyone see a different pattern? Go ahead. They're all perfect squares. 0 is a perfect square because 0 times 0 is 0. 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. So this is 0 squared, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. These are all of your perfect squares up to 15 squared. So our next one would be 16 squared. And what's 16 times 16? Okay, and then 17 squared. And 18 squared. 324. And 19 squared. 361. And 20 squared. 400. So you have to know or be able to recognize all of these perfect squares. You don't have to memorize them. You need to be familiar with them. The reason you don't have to memorize them is because you can use a calculator. So if you're ever unsure on if something is a perfect square or not, you can just put it in your calculator. So the first one we need to sort is 169. If you are not sure if 169 is a perfect square, you type in 169, and then your square root button is right here. It's next to the division sign. So 169 square root, and you get 13. 13 is an integer, so 169 is a perfect square. Okay, is 75 a perfect square? No. 16? 0? Okay, this one's important. On your test, you're going to have a question that says circle all the perfect squares, and people forget to circle 0. You have to remember that 0 is a perfect square because 0 times 0 is 0. Is negative 10 a perfect square? No. Never negatives. So negative numbers are never perfect squares. Is 1 a perfect square? Yes, 400? 25? 1010? 111? 81? 31? 9? 4.2? Decimals are never perfect squares. Negative 100? No, because it's negative. That one's important. If they're asking for perfect squares, negative numbers are never perfect squares. Taking the square root of negative 100 is different than the negative square root of 100. So negative square root of 100 is okay. Square root of negative 100 is not okay. Is 15 a perfect square? No. Okay, who has questions? Okay. You're going to have a question like number 10 on your test. You're going to have a question like number 7 on your test. Yes, Yassine. You're always allowed a calculator. Are there other questions? Okay. So, this is your warm-up. You're going to hold on to it. On the back is the scavenger hunt. This is one of our activities for today. So you can leave that out if you want. The next paper you're going to pick up says notes approximating squares or square roots in simplest radical form. So find this paper. It should have been the third paper you picked up. one says approximating square roots. If I am going too fast or you don't understand something, let me know. But this isn't very difficult because you can use a calculator. I'm going to explain it as if you couldn't use a calculator so you kind of understand where we're getting these numbers. So this is, what if the number isn't a perfect square? How do I find the square root? If it is not a perfect square, then it's going to be an irrational number. Can someone tell me what irrational means? Go ahead. It's important. Go ahead. What'd you say? Not a normal number? Okay, it's not really a normal number, James. It is not rational, so irrational is the opposite of rational. Salim? It's a non-repeating, non-terminating decimal. So it's a decimal that goes on and on without a pattern. So irrational numbers are kind of crazy. Pi is an irrational number that you've probably heard of. The other type of irrational number we're going to learn about this year is square roots of non-perfect squares. So since we can't get an exact number, we're going to identify the two consecutive numbers that the square root will lie between. Can someone tell me what consecutive means? Good, Yassine. One after the other. So what's an example of consecutive numbers? 1 and 2, 2 and 3, 5 and 6. Something that's not an example would be 10 and 20, 11 and 14. Those are skipping numbers. So the definition of consecutive is back to back or one after the other. So 1 and 2 is an example, 5 and 6, 10 and 11, -3 and -4. Sorry, we should write these in order. -4 and -3. Okay, example 1 says, between which two consecutive numbers does the square root of 57 lie? If you're using a calculator, you type in 57, then you hit the square root, and the square root of 57 is 7.5498, etc. What two integers does that fall between? Go ahead. 7 and 8. The other way of doing this is you have to know your perfect squares. So 57 is a little more than 49 and a little less than 64. So the square root of 57 will be a little more than the square root of 49 and a little less than the square root of 64, because 57 is between 49 and 64. So the square root of 49 is 7, the square root of 64 is 8. So you find the square root that's a little below, or the perfect square that's a little below and a little above that number. That's all you have to do. I'm going to do example 2, and then I'm going to let you guys do these ones on your own. So example 2 says, which pair of numbers are both between 5 and 6? Between does not mean equals 5 and 6. The square root of 25 is 5. The square root of 36 is 6. So that's not going to be between 5 and 6. That is 5 and 6. B is an answer a lot of people choose because they see numbers that match up and they're not reading the question. So we're looking for square roots between the square root of 25 and the square root of 36. The square root of 22 is too low. The square root of 28 and the square root of 38 is too high. 28 was okay, 38 is too high. The square root of 27 and the square root of 35 are good. We can check our answer just in case. 27's square root is 5.1. 5.1 is between 5 and 6. The square root of 35 is 5.9. 5.9 is between 5 and 6. So D is the correct answer. On example 4, add in the negative. So it reads the negative square root of something lies between negative 14 and negative 15. And then you guys do these 3 problems. So the you try number 1, example number 3, and example number 4. Alright, volunteer for this first one. Abdullah? What'd you say?
D.
Oh, okay, D's fine. D is the square root of 13. The square root of 13 is 3 point something, which is between 3 and 4. Volunteer for this one above example 3. Xavier? Negative 5 and negative 4. The square root of 18 is 4.2. If you want to know the negative square root, you put the negative on at the end, and you can read that's negative 4.2, which is between negative 5 and negative 4. And example 4. Go ahead, Tomas. What'd you say? 215. 214. Okay. So, notice when I put in this answer, I put in the number. This says the negative square root of some number lies between negative 14 and negative 15. So my answer is 214. If I take the square root and make it negative, my answer is negative 14.6. Negative 14.6 is between negative 14 and negative 15. Did anyone put a different number in the blank? Go ahead, Sam.
I put in negative 200 or 200.
200?
Yeah.
Okay. So you're not putting a negative in there. Negatives are bad. It already says the negative square root in the problem. The square root of 200 is 14.1. If we make it negative, it's negative 14.1, which is between negative 14 and negative 15. Did anyone put a different number in the blank? Could someone give me a range of numbers that would be acceptable? Go ahead, Xavier. 201, 202, all those are okay. What is the biggest range of numbers that we could have? Like, what's the smallest number I could write and the biggest number I could write? Go ahead, Yassine. Okay, and what's the biggest? $224 is definitely the biggest. Because 15 squared is 225, so 1 less is 224. 14 squared is 196. 1 bigger is 197. So the numbers I can put in here are 197, 198, 199, 200, all the way up to 224. 225 is too big because it equals 15. It's not between 14 and 15. Okay? You guys have any questions yet? Okay, hopefully you found that relatively easy because the bottom part gets harder. Part 2 of these are simplest radical form. So last year you probably learned what a square root is and took square roots of perfect squares. This year we're approximating them a little bit, and then we're writing them in simplest radical form. So, in order to do that, we have to know a few vocabulary words. The first one is a factor. The factors of a number are those numbers that divide exactly into the number. So factors of 10, 2 times 5. Factors of 16, 2 times 8, or 4 times 4. Factors of 12, 2 times 6. 2 times 3 times 2, 3 times 4, all those are factors. A prime number is a whole number with exactly two factors, one in itself. And when I ask you to make a factor tree, we are splitting the number that you're factoring into two factors, and then we will continue to split numbers up until there are only prime factors left. As soon as we find the prime factorization, or all the prime numbers that multiply to get to that bigger number, we will circle the prime numbers and write prime factorization using multiplication. Because we're just rewriting the number in a different form. And to get to that number, we're multiplying. Okay, turn the page. Alright. So I'm going to do 2 examples, and then you are going to do 2 problems on your own. So example 5 says, put the square root of 75 in simplest radical form. So first I'm going to write that number inside the square root, because that's what I need to find the prime factorization of. In order to find all the prime numbers that multiply to 75, we're just going to start with one factor. And I know that 3 times 25 equals 75. 3 is a prime number, 25 is not. But 5 times 5 is 25, and 5 is prime, and the other 5 is prime. So 75 is equal to 3 times 5 times 5, which means the square root of 75 is equal to the square root of 3 times 5 times 5. So your first step is breaking it up into all the prime factors. 3 is prime, 5 is prime, 5 is prime. If you don't have all prime numbers, you have to keep breaking them up. When you're at this step, you need to circle a pair of numbers, as many pairs as you have. 5 times 5 is 25. That's a perfect square. That's why I'm circling pairs of numbers. And the square root of 25 is 5. So when I circle a pair of numbers, I take that pair and I write it down on the outside of the square root, because I have gotten rid of a square. If something does not have a pair, it gets left on the inside of the square root sign. So the 5s had a pair. I took the square root of 5 times 5, which was 5, and then I left the other number on the inside. So the square root of 75 is equal to 5 times the square root of 3. If you want to check your work, the square root of 75 is 8.66025. To do 5 times the square root of 3, you do 5 times 3 square root. This is the square root of 3. To get that multiplication, you hit equals. Now let's multiply that by 5. You get 8.66 again. You could also do 3 square root times 5 equals, and it works because multiplication is commutative, meaning you can change the order that you multiply your numbers in. Sorry. Yes?
So after you figure out that 3 times 5 times 5, what's the point of addition?
To simplify it, so the square root of 75 is equal to the square root of 25 times the square root of 3, and the square root of 25 can be simplified, and then you're left with the square root of 3. So it's like when you simplify your fractions, you find a common factor and you divide them both. Simplifying radicals is like simplifying fractions. It's a nicer way to look at the numbers. And you're also going to use this a lot in Algebra 2, when you have to factor terms out of expressions and equations. So this is just a little introduction so you can get comfortable putting things in simplest radical form.
So, you have to go like, you have to go straight to the smallest one, or smallest factor, so you can keep going?
No, so you could have also done the square root of 75. Instead of I did 3 times 25, you could do 5 times 15. 5 is prime. 15 is 3 times 5. 3 is prime and 5 is prime. So you get the same thing. 5 times 3 times 5. Like they're the same numbers. 3, 5, 5, 3, 5, 5. So then when you write it, you still write 3 times 5 times 5. You still circle your pair of numbers. You still write them on the outside. So it doesn't matter what numbers you start with when you're doing your prime factorization. At the end, you'll always have the same prime numbers.
But if you're comparing numbers, they have to be the same number, right?
They have to be the same number. Sometimes you'll circle more than one pair of numbers too. Go ahead.
Will there always be like a pair of prime numbers that are
If you're doing the square root of 30, I don't think this works. So 30 is 3 times 10, 3 is prime. 10 is 2 times 5, 2 is prime and 5 is prime. So when I rewrite this, it's 2 times 3 times 5. There are no pairs of numbers, so the square root of 30 is already in simplest radical form. On your test, you will always be able to simplify it further. But in real life, you can't always simplify them because they're already simplified. Okay? Another example. I'm going to do this one that's the square root of 96 because it's a bigger number. And I think there's more things to circle. So what are two numbers that multiply together to get 96? Go ahead, Tiziano. 3 and 32. 3 times 32 is 96. And 3 is a prime number. 32 is not prime. So what two numbers make 32? 8 and 4. Okay. Neither of these numbers are prime, so we got to keep going. What two numbers make up 8? 2 and 4. But 2 is prime. It's the only even prime number. What two numbers make up 4? 2 and 2. Again, 2 is prime, 2 is prime. And don't forget about this part. What two numbers make up 4? Okay. So this one we have a lot more prime numbers that multiply to get 96. So the square root of 96 is equal to 3 times 2 times 2 times 2 times 2 times 2. We should count and make sure we have enough 2's written down. There are 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5. So I got all of my prime factors down there. So first step is writing them all out. Our next step is going to be circling pairs of numbers. Here is one pair of 2's. I circled up that pair because 2 times 2 is 4 and the square root of 4 is 2, so I'm going to write it on the outside of the square root. We're not done yet though because we have another pair of 2's. 2 times 2 is 4, and if you take the square root you get 2 again. But we're left with two numbers inside. This 3, there's not another 3 on the inside. And this 2 does not have another 2 on the inside to buddy it up with. We're not done yet, though, because we actually have to multiply and simplify all the way. 2 times 2 is 4, times the square root of 3 times 2, which is 6. So my answer is 4 times the square root of 6. Do not ever leave multiplication in your answer other than between your outside number and the square root, because it's not simplified. Do you have a question, Stefano?
No.
Okay. The other way of writing this, if you wanted to see it, is the square root of 4 times the square root of 4 times the square root of 3 times the square root of 2. These two numbers are what can be simplified. The square root of 4 is 2. The square root of 4 is 2. 2 times 2 is 4. And then the square root of 3 and the square root of 2 we bring back together as a square root of 6. Questions? Alright, so you guys are going to do example 6 on your own, and this you try on your own. So you have 2 problems to do on your own, so you can kind of figure out 16 times 2 is 32, 4 times 4 is 16, 2 times 2 is 4, 2 times 2 is 4. So we have the square root of 2 times 2 times 2 times 2 times 2. Circle up a buddy, write it down. I circled up a pair of 2s, so I write down 2. Circle up a pair of 2s, write it down.
16 has
8's not a prime number, though. 4 times 2 is 8. We will all get the same answer if you factored it differently. 2 does not have a buddy, so we're going to write the square root sign and write a 2 on the inside because there's nothing else to pair it with. 2 times 2 is 4 times the square root of 2. So even if when you broke this up you did 16 times 2 and then 8 times 2, 8 is 4 times 2, 4 is 2 times 2, so 1, 2, 3, 4, 5 2's, 1, 2, 3, 4, 5 2's. So you get the same way, you get the same answer as long as you're breaking up all of your composite numbers. The square root of 40, 40 is 10 times 4, 2 times 20, whatever you want. 10 is 2 times 5, 2 and 5 are both prime. 4 is 2 times 2, the 2's are prime. When I write this down, we have 2 times 2 times 2 times 5. 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. Circle up a pair of 2's, write it on the outside. This 2 and this 5 does not have the same number that it can be paired with, so the 2 goes on the inside and the 5 goes on the inside. 2 is left on the outside. 2 times 5 is 10, 10 on the inside. 2 times the square root of 10. Questions? Yes. Those are your answers. Alright, take 2 minutes and write a summary. What are the most important things to remember when expressing a square root in simplest radical form? So you could write down the steps that we used. You could write down mistakes that you made that you don't want to make again. You could write down a way to remember it. Just write a summary of